I'm going to talk about the Dandy Candies problem that we started in class today. So we've got these four boxes, A, B, C, and D, and each of them have 24 individually wrapped smaller boxes of candy, which are cubes. And so each one of these has a volume of 24 cubic units. They also have a surface area, which is the box, right? So the area of each of the six faces. So top, bottom, front, back, side, side. And then there's a ribbon length. And the ribbon's not the same on all sides, right? On the top here, it's got the cross, and on the side, it's just one. On the bottom, it would be the same as the top. And so we have to think about that as we look at the image, how that would look. So here's a table that contains a lot of information for this problem. So we've got the box letter, we've got the base of the box, and this is important to distinguish so that we can, it'll help with the ribbon, I think. But our base for that first one is, it's a long 24 by 1 or 1 by 24, and the height is 1. And notice the volume is always going to be the base times the height, or length times width times height. The surface area is a little more complicated, so I left a room down below to do that calculation. And then the ribbon is kind of equally complicated. And notice what's highlighted in red here. The volume is cubic units, right? This is space. Surface area is square units, and this is flat space, like a floor, or like a box, like paper. And the ribbon is linear units. So we have 3 different dimensional measurements. So here's an example of how you would show calculations for each of these. Volume, again, length times width times height. And it's always nice to write this in. And playing with little cubes can help you recognize this. You might ask yourself how many cubes, if a Rubik's Cube, a 3 by 3 by 3 was solid, just made of cubes, how many cubes would be in there? So this is 1 times 24 times 1, so it's 24 cubic units. The surface area, we need to break this apart. So 6 different faces, and actually not 6 different faces, 3 kinds of different faces, and then their opposite. So front, back, side, side, top, bottom. And this is just kind of how I call them. Sometimes you get shapes that are cubes and all of them are the same, and you can do this a little differently. Let's see, there's no cubes here. There are shapes like B where the side, or I guess the front, is the same as the top. So you could do that differently too, but this works in every case. This is like a box or a rectangular prism. So the front and the back are 1 by 24. So we could say 1 by 24 by 2. That's the area for the front and the back. The sides are 1 by 1 on that long skinny one. And there's 2 of those. And the top and bottom are 1 by 24, and there's 2 of those. So we get the area for each of these, and then we add them up. And that is, let's see, 98, not 96. Oh, this is 96, right, for the front, back, top, bottom, and then the side adds 2 more. So yeah, so we get 98 total. This is a kind of a lengthy expression here. This is a surface area expression. It's got, you know, the front, back, side, top, bottom, all in one. And notice we got to pay attention to Pima. Don't want to Pima pants. So parentheses, exponents, multiplication, division, and addition comes last. And so red would come first, then green, and then the yellow. The ribbon, we can just take a look back at the picture and try to piece this together with the front, back, side, top, bottom again. The front, back is, let's see. Oh, look at this. Even though it's a huge long box, we only have one linear unit of ribbon. So we get 1 on the front and 1 on the back, so 1 times 2. The side and side, also 1 times 2. And the top and the bottom, they go all the way down the long 24, and they go across. So 24 plus 1 times 2. And so we get 54 units. And that's how you're going to do that. And you want to do that for each of the boxes and then see what the table says, which is the best way to box these things.